Here's a projectile that is launched with an initial velocity of 18.6 meters per second at 28 degrees above the horizontal. Find the time the object is in the air, and then there are a few other things we're going to find as well. Anytime we have a projectile launched at an angle, the first thing we want to do is we want to find the initial y component of velocity and the x component of velocity. That is, we want to find Vx and we want to find Vy initial right here. So let's do that. We're going to take Vx as being, look at our triangle, the hypotenuse times the cosine of 28. And that comes out to be 16.4 meters per second. Let's do the same thing with Vy initial. Again, we label this initial, and we don't label Vx because Vx is constant. That 16.4 meters per second is good for the entire time that this football is in the air. But Vy initial is only good at the first instant. So that's going to be 18.6 times the sine of 28. And to three significant figures, I get 8.73 meters per second. This is in the horizontal direction. That is in the vertical upward direction. 8.73 meters per second. For the umpteenth time, anytime we have a projectile, we need to choose a direction to be positive in the vertical direction, and therefore have a direction that is negative. So if we choose this to be positive, which I'm going to choose upward to be positive, that means that our acceleration in the y direction necessarily has to be negative because the acceleration points towards the Earth. All right, let's find the time that the object is in the air. We're going to assume that this football lands at the same elevation as what it was thrown at. So the time that it takes to get to the top and the time that it takes to come down are going to be numerically equal. So I'm going to calculate the time to the top. And at the top, Vy final is going to equal 0. The up and down velocity at the top is going to be 0. Now, the x velocity component is still good at the top, but at the top, Vy final is going to be 0. The equation we can use is Ay is equal to Vy final minus Vy initial divided by time. That term goes away. Time to the top, the opposite of Vy initial divided by Ay. And according to my calculations, that comes out to be 0.890 seconds. But the question is, how long is this in the air? It's going to take the same amount of time to come down as it took to go up. So the time that it's in the air, which is the question, is 1.78 seconds. Now, what's the maximum height that the object attains? Again, any of these equations here that have dy, because that's what we're talking about with maximum height, we're talking dy. Any of the equations that have dy in it are okay. So this one would be fine, this one would be fine, this one would be fine. There is a slight danger to using the second one or the last one in this case because they depend on the time that we've already calculated. However, because I don't want you to be afraid to use a previous answer in finding something later, I'm going to go ahead and use this one to find dy. But I need you to understand that I hope you can see that if we messed up the time calculation and then we use that time in calculating dy, then dy is going to be messed up. But we're going to trust ourselves that our time was okay. And so I'm going to use this last equation right here. So let's do that. Vy initial times time plus 1/2 Ay time squared. Now this is going to be the time to the top. Vy initial What was it? Do I scoop this up here? You can see in the upper right corner. Vy initial was 8.73. That was a positive number. I'm going to write that here. 8.73. The time that it takes to reach its maximum height is this 0.89 seconds, not the 1.78. So that's the first term, plus 1/2, and this is really important, that AY is a negative number. Gravity has, you might say, a subtractive effect in helping us figure out what this dy is. I'm going to go ahead and calculate that real quick so you can see those numbers. 8.73 times 0.89, 7.77, and then this quantity is a negative number, negative 3.89 or so. And so when you figure that out, you're going to get about 3.88 meters. That's how high this football goes. If you had used either of the other two equations on the equation sheet, you would have got the same answer. We've got one more bit to this, and that is, what's the projectile's range? Hopefully we're comfortable now saying that the range is dx, and there's only one equation, isn't there, to find dx, and it's vx times time. The vx is 16.4, and we want the total distance horizontally that this football goes. And if we want the total distance horizontally, we're going to have to use the total time, which I'm pointing at right now, 1.78 seconds. This 0.89 was the time that it takes to get to the top. And so that was the time that we used when we were calculating the maximum height, because that was the time that was involved there. But to calculate the total range, you need the total time. So Vx is 16.4 meters per second, and the time is 1.78 seconds. You can see the second units cancel. The three significant figures, 29.2 meters. That's how far that football goes before somebody catches it.